it's always worse than expected. Records broken, unprecedented rates, and never, nah, don't worry about it, we actually overreacted. One day, maybe we'll wake up and it will all be a dream. But until then, welcome back to the nightmare that is climate science. I'm back this week with another roundup of the climate news that you really need to hear. And actually, I had a really nice discussion over on Patreon with some of my subscribers there. They were suggesting lots of cool new topics, and we had a good chat about the stuff that's actually going to end up in this video. And if you want to join them and get early access to videos, then you can. The link is up here and down here. All right. Let's get into the video. First up is the scientific evidence that shows that the rumors are true. The rate of global heating is accelerating. This is a paper by two very well-respected climate scientists that basically says, yes, 2023 and 2024 were record hot years and the first calendar year above 1.5 degrees. Previous studies couldn't really say that the rate of heating had accelerated because the data were just too noisy. But this study says, yes, the anecdotal evidence does align with the data. The trend has ramped up. The rate of warming is faster than ever before. In fact, since 2015, it's been faster than any previous decade. And scientists were previously kind of worried about the statistical significance, and this is a scientific measure of how sure we are about something. And these two remove the influence of volcanoes, El Nino, and solar changes, so changes in the sun's output, and they looked at the trend with those things removed. So basically, they took the noise out of the observations. And it shows with 98% confidence that warming has accelerated. Now, to do this, they looked at several different data sets, and they found the same thing across all of them. There's a long-term increase, there's the infamous pause around about the early noughties, and then there's a dramatic uptick of the rates of warming since 2015. So this is one of the charts from the paper, and it shows the rate of change in temperature, so the rise in temperature, per decade since the 1970s. So up until 2015, it was around 0.2 degrees Celsius per decade, i.e. it would take 50 years to warm by 1 degree Celsius. Now, however, that's doubled to nearly 0.4 degrees per decade. The scientists looked at why this was as well, and there are a bunch of different hypotheses, and the main one that is leading in the literature as a whole is that it's a reduction in the aerosol masking effect. So aerosols, tiny particulates in the atmosphere, can cause clouds to form, and it can reflect lots of the sun's energy back to space. Also, the aerosols themselves can have an interaction with the sun's radiation. We don't have time to go into the many ways that happens. And there was some regulations that came in around the sulfur dioxide impacts of shipping. And those regulations meant that fewer aerosols were being emitted from ships, and that had cooling effects. Also, it's another interesting point because air quality regulations around the world, which improve our health, which improve the air that we breathe, improve our well-being and our general societies and our quality of environment, can sometimes have a negative effect on the climate. So it can actually cause a warming. There are lots of trade-offs between air quality and climate change. Often they align, and often improving air quality and improving climate go hand in hand. However, in some cases, that's not necessarily the case. The final paragraph of this paper really rams it home. It says that stopping this trend is in our hands. And as soon as we get to net zero emissions, the rate of warming will stop to zero. Obviously, we will have already warmed the climate, and that will have negative consequences. But they say, in the current political climate, it seems abundantly clear that warming is going to continue, if not accelerate faster. And if the warming rate of the last decade carries on, then we will breach the Paris Agreement of 1.5 degrees by 2030. That's 4 years away. That's really soon. So this is another example of how warming is happening faster than expected. The changes that we're seeing in our climate are happening more dramatically and more quickly than expected. And we know it's already having really negative impacts, and it will continue to do so. Now, in other bad news, another paper that's just come out shows that sea level rise estimates have been underestimated in a lot of different coastal hazard assessments. That's especially in the global south, and this is mostly down to the use of less rigorous scientific techniques. Now, I'm going to get into the weeds here because there's some technicalities that make this semi-interesting that explain this. But if you're not interested in the juicy details and you just want the main headline messages, then skip ahead to this timecode. So the reason that sea level rise has been underestimated, according to these authors, is a bunch of things. So measuring sea level rise is actually not that easy because it requires us to know how high the underlying ground and sea level actually is. And that sounds relatively straightforward, except the best way to know how high the Earth's surface is, whether it's ocean or land, is by flying aircraft over the surface and firing pulses of light down, measuring how fast they come back, and using that to measure the exact distance between the aircraft and the surface. And that is what we base our elevation data on. Mostly that aircraft data is available in the global north. Elsewhere, we rely mostly on satellites. The problem is, under the hood, satellites actually mostly still rely on lots of assumptions about various different elements of the Earth system that convert what they actually measure, which is like zeros and ones or laser retrievals, into the thing that we're actually interested, like in this case, surface height. But sea level and land level is constantly changing, especially in regions that are sinking because of subsidence or in areas that are rebounding after the last ice age and therefore rising, or the last glacial maximum, if we're being precise. So when people use those satellite-derived measurements of elevation to do their coastal hazard evaluations, which is basically how many people are going to get impacted by sea level rise in this particular place in the next 50 years or so, then they should be referencing that satellite data against measurements of local sea level rise. The thing is, that doesn't often happen. And instead, they use something called a geoid, which is basically a model that tells you about the height of the planet in a particular place based on gravity. And I won't go into that, but there's a bunch of assumptions in that as well. So basically, the summary is that virtually all assessments of coastal flooding and coastal flooding risk and sea level rise do not use the most rigorous techniques to measure sea level rise. And this can lead to big uncertainties in the level of risk that they're planning for. This is especially true in areas of the global south, especially, which have higher rates of sea level rise often and also less money available to do the adaptation work that is required. It's also kind of bonkers from a science perspective because sea level is measured to like millimeter accuracy. Well, better than millimeter accuracy. So to just like throw this information out of the window, then use much less precise techniques is kind of like putting your two fingers up at the observations. It's a bit strange. We also know that sea level rise has doubled in the last 30 years or so, right? And this measurement difference could have a big impact, right? So this paper shows that for a 1 meter rise in sea levels, this measurement difference could have underestimated the amount of people that are exposed to risk by 2/3. And it could translate into like a third more land, if we calculate it properly, being exposed to coastal flooding, coastal risks. And these are hazards that really do have a real significant impact. You know, it's sea level rise that threatens people's homes and livelihoods and everything, but it's also erosion, it's also storm surges, it's tsunamis, it's flooding. And the estimate is that it's up to 130 million more people, mostly in the global south, that could be at risk of sea level rise or coastal hazards associated with sea level rise. It brings the impacts of climate change forward in time. So it means more people will be affected more quickly. Around half of sea level rise comes from ice sheet losses. And another paper came out recently looking at Antarctica. So this is obviously one of my favorite topics. This study maps the risk of sea level rise from individual glaciers and drainage basins. Now, a drainage basin is an area where all the ice flows into a single exit point, and that could be a glacier or it could be an ice shelf. It's kind of like a river drainage basin. Gradual sea level rise is a problem in Antarctica, but what's more a problem is the threat of tipping points. So this is a threshold beyond which change becomes irreversible on human timescales. So if you lose a glacier, for example, it doesn't grow back overnight. So it takes a really, really long time and a lot of cooling to restore its previous condition. Now, these scientists look at different temperature thresholds that will tip different drainage basins and then the likely sea level rise contribution from each of these. And whereas we were talking about millimeters per year in terms of sea level rise before, this is like meters of sea level rise, obviously over a longer time frame. So this is a really nice figure, I think. It shows a map of the Antarctic with all of the drainage basins drawn on. The bigger circles indicate a bigger contribution of that particular drainage basin to sea level rise. And the darker the colour of the circle, the lower the temperature threshold. So the more likely it is to tip sooner. So these authors show that the first threshold in West Antarctica is probably between 1 to 2 degrees Celsius, above pre-industrial, that is, which agrees with a lot of previous studies that I've talked about on this channel. At that level of warming, we would lose about 2/5 of the West Antarctic's ice volume. That's pretty crazy, because West Antarctica contains enough ice by volume, I think, about 5 meters, 3.3 meters of sea level rise potential. So here's another nice one, and it shows the relationships between the level of heating and the sea level rise contribution from tipping various different basins. I mean, surprise, surprise, the ones that we always hear about are most at risk. So that's the Thwaites, the Doomsday Glacier, the Pine Island Glacier, but also the west of the Ross Ice Shelf, which is the Saiple Coast. And then there's also parts of the Ronnie Ice Shelf, which for me is a genuine surprise, because the Ronnie Ice Shelf is often thought to be big and cold enough to be relatively stable. So maybe I've not been keeping up with the literature, but that is, to me, a little bit more surprising. The different areas of Antarctica are colour-coded. So we've got blue for East Antarctica and orangey reddy for West Antarctica. Unsurprising that the West Antarctic ones are associated with much lower levels of warming, so more likely to tip as the climate heats. And you can also see on the right-hand side these thresholds of temperature rise that are associated with the various different scenarios, likely scenarios of climate heating. So some of them may not this century be lost, particularly the ones in the East Antarctic. Depends on how much we burn fossil fuels, depends on how much heating we end up with. But the other thing is that lots of those West Antarctic ones, those 3 earlier, the Thwaites, Pine Island, Ross West, and Ronnie, 3 different drainage basins, 4 glaciers or ice shelves, are already, at the present day, likely to tip, which is pretty bonkers if you think about it. The authors go on to say that the loss of Thwaites is likely at 1 degree above pre-industrial temperatures. Just a reminder, we are well above that right now. And the study shows that 70% of the ice will be lost at that threshold. So that's just under 1 meter of sea level rise over the long term. Again, something that's widely reported, but I think bears repeating. So we are committed already to basically another meter of sea level rise because of Thwaites alone. So this figure confirms what we already know in lots of the literature, that some areas of Antarctica are more stable than others. So East Antarctica, the blue colours, tends to be more stable, and the threshold for tipping the East Antarctic is a bit higher. The range, which is quite large in this study, is 2 to 5 degrees, but most of that lower end comes from one particular basin. So this is the glaciers in Wilkes Land, which is on the kind of the western bit of East Antarctica, which is the Cook, Ninnis, and Mertz glaciers. And the threshold in this study seems to be between 2 and 3 degrees. And that would lead to about, just over 1 meter of sea level rise. I mean, again, pretty likely we are on track, if all of our pledges, commitments, and targets get met, to achieve 2.5 degrees this century. I'll leave it up to you to say what you think will actually happen. I think, given the fact that things are worse than expected and our world leaders don't seem to give a shit about any of this, that we're probably likely to get a bit more warming than that. So that's, again, another meter of sea level rise that is probably, by the end of the century, going to be baked in. Now, sea level rise happens over the long term, but it is committing us to huge amounts of change over multiple generations. This is change that cannot be reversed once the threshold is crossed, once the change is initiated. So with all of this, perhaps it's not surprising that people are feeling scared and people want some change. And obviously, it's not just climate change that is screwing people over right now, because we have got more major wars happening across the world than most of us can remember in our lifetimes, a total rejection of the rule of international law, and most people in most countries facing a crippling cost of living crisis. So it was nice to see that in my silly little island, at least, the Green Party had another win. One glimmer of nice news amongst the dark. So this was the first Westminster by-election victory for the Greens. And it left the current government, Labour, the Lib Dems and the Tories right at the bottom. So the main parties were just left in the dust. We won't talk about the fact that the right-wingers came second because I want to not throw myself off a cliff today. But the really great news is that a female plumber from Manchester, won the seat, and she won 2/5 of all the votes cast. And she won because she said what we're all feeling and thinking. Life is getting harder for most of us, whilst we watch billionaires and despots bomb civilians to distract from their heinous crimes and line their pockets in the process.
Because life has changed. Instead of working for a nice life, we're working to line the pockets of billionaires. We are being bled dry, and I don't think it's extreme or radical to think working hard should get you a nice life.
So this was one nice piece of news amongst the show, and it shows that people are done with the major parties that represent the status quo. So I guess if you needed it, this is your call to get involved with the Greens, to do campaigns work, because it can actually make a difference. And maybe it's time to ditch the two-party system. Trump has thrown the rule book out the window, so why can't Americans do the same, I suppose? Obviously, that's facetious. I think it's probably naive to assume that that could work in the USA. But my point is that grassroots change can have an impact. We actually had a conversation about the American Green Party over on Patreon, and I always value hearing the thoughts and comments of my subscribers. For those of you who already support me on Patreon, thank you so much. I'm immensely grateful. And for everyone who doesn't, then if you'd like to, you would be very welcome to join in the conversation. I'm super grateful for any contributions that you can make. They help me make these videos. They help me make these videos more often and better, ideally. So if you want to join them, you can do over at this link. Otherwise, I will catch you next time and watch one of these next. I think you'll like it.